Okay, page 96. So last day, what we looked at is we looked at, let's say we had an oxygen and it had 2 electrons shared with a hydrogen and some lone pairs, 2 electrons shared with a hydrogen, and it would look like that, yes? And we could show that also this way with a line instead. This is what we call a single bond. Single bond. Single bonds, 2 shared electrons.
Thank you for participating in our fire drill. At this time, we ask that teachers be brief with the discussion questions provided in the email sent earlier this week.
We're not going to do that. Okay. Double bonds. How many shared electrons do you think are in a double bond?
4.
4 shared electrons, yes. And a triple bond, how many shared electrons? 6 shared electrons, 3 pairs. 3 pairs. Okay, we're on page 96, 96. All right, so here we're going to form an oxygen molecule out of 2 oxygen atoms. And each oxygen atom has 6 valence electrons to work with. All right, and if we go through the process that we did yesterday, where we're like, okay, let's just share those 2 electrons there, then what that will mean is that the oxygen on the left, how many electrons does this oxygen have? 7. Is that good? No, because what do atoms want to have? Atoms want a complete octet. So they want 8 electrons. So 7 electrons on the left. How many on the right? The right-hand oxygen has 7 electrons. And we have a problem, right? It's not a happy little oxygen. What is good, though, is that we started with 6 and 6, which is 12, and we finished with 12. So at least we have the right number of electrons in the structure, but the structure doesn't give us a complete octet, so it's not good yet. How could we fix that? Well, what if we put these electrons over on, what if this guy shared both of his electrons, the left hand shared both of his electrons with the one on the right? That would give the one on the right 8 electrons. But it would give the one on the left only 6 electrons. Yeah? So that's a problem. And you are not allowed to just stick in a couple extra electrons in there. You can't be like, oh, that oxygen needs 8. Ha 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 ha. Because that would give it 14 electrons in total, and you only have 12 to work with. You cannot just add in extra electrons. It's not allowed. Okay? So we cannot satisfy both oxygens by sharing only 2 electrons. So let's try sharing a multiple of 2. Let's try sharing 4 electrons. So we're going to share these ones, that unpaired set, and we're going to share that unpaired set. And do you remember, how many bonds does oxygen tend to form? Right? oxygen has 2 gaps, so it tends to form 2 bonds. And so what we got now is we have the oxygen on the left has 2, 4, 6, 8. The oxygen on the right has 2, 4, 6, 8. So we have 8 electrons for the oxygen on the left. We have 8 electrons for the oxygen on the right. And I'm going to get rid of all that stuff that I've drawn on there because it makes it look messy and confusing. So we have 8 electrons and 8 electrons, but we still have 12. Okay, so we have fixed our problem without adding extra electrons, which we are not allowed to do. We can replace those electrons, these guys here, the shared electrons, with lines. So 2 lines is a double bond. So if you were counting your electrons, you would say, I have, for the oxygen on the left, I have 2. This top bond is 4, the bottom bond is 6, and then 8. If I'm counting for the oxygen on the right, I have 2 up here. I have the top bond is 4, the bottom bond is 6, and that lone pair is 8. Yes? And how many bonds does oxygen have in this structure? 2 bonds, which is what it likes to have. I will be honest with you, there are occasions when oxygen has 3 bonds, but it's unusual, okay? And we have tricks for dealing with it when it's not normal, okay? So oxygen has formed 2 bonds. There we go. We did not add electrons to complete the octet. Very good. N2. Well, we're going to run into the same problem because nitrogen has 5 electrons. If we share those, this nitrogen on the left has 1, 2, 3, 4, 5, 6 electrons. This guy has 1, 2, 3, 4, 5, 6 electrons. Is that a happy structure? Is 6 electrons around an atom happy? No. Do we have the correct total number of electrons, though? Yes. Okay, so 5 plus 5 is 10, so that part's good. And we can't just share, let's try forming a double bond, seeing if that fixes it. Okay, 2, 4, 5, 6, 7. Now we have 7 electrons. And the guy on the right is identical, so it has 7 electrons. So you cannot satisfy nitrogen with a double bond. You can't just share 4 electrons. How many electrons should you have in between the 2 atoms? You should have 6. Okay, and so what we're going to do is we're going to have that top pair shares, the middle pair shares, the bottom pair shares, and we end up with 6 shared electrons. So 6 of those belong to both nitrogens. So they each have 6, and then they each have, what do we call these electrons here? What do we call those ones that aren't bonding pairs? We call those, starts with an L, a lone pair. So this nitrogen on the left has 1, 2, 3 bonding pairs and a lone pair. So that's 4 pairs altogether, which makes 8 electrons. Okay? And the one on the right also has 6 electrons, 6 bonding electrons, and 1 lone pair gives it 8 electrons. So now we have 8 electrons and 8 electrons. Okay, now you guys are going to try these. Numbers 1 and 2 are okay. Number 3 is harder. This violates the tendency of carbon to have 4 bonds and oxygen to have 2 bonds, so don't try to make that happen. Okay, but give them a try. Mainly, this is to show you that it's kind of hard to figure out compounds with double bonds. So just do your best, and then I'm going to later show you a method that makes it easy. Okay, so just do your best for now. Try these out. See how they go. Yeah. Yeah, for sure. Yeah. Are you sure? Okay. Okay.
For the first question,
Yeah.
don't am I counting both oxygens?
Yes. Yes.
So would I write like O?
Who's going to go in the middle?
Yeah.
So for CO2, you have to think who's going to go in the middle. Who's going to be the central atom? Oh, thank you. Yes. Very good.
So yeah, I'm looking at the place. They're gonna make 2 bonds of each. But I'll be like, whatever. I think what's in the center is like what has measurements.
Yeah, whoever has the most hands goes in the middle. Perfect. And this is why I have to do this, because then you'll be like, oh, you have a method that makes this easier? And I'll be like, yes, I have a method that makes this easier. Nice. Almost good here.
Your shift's on that line, and you have to walk back to the station, go back. So you have to watch it. Yeah, when you're like, big one day. I would say it's like 1 or 2. That sounds fun.
I mean, unless I have it open.
What time do you start?
Well, if you're closing, I mean, if you're closing out one, that's probably like a Friday. If you're closing, it's either from like early as like 4:30, but most of the time it's like 5 to like 6. Closing. Yeah, but like.
I guess like it's like that. Yeah, Thursdays are rough.
But then after school is like.
Oh, you use Mondays after school?
Cause like fucking, if it was like a Thursday or something, it would still be pretty busy. Fucking Khaled works Friday, Sunday. Go fucking, you like, you only work Fridays and Sundays, so the other day you switch to shit. Like, you had a call and fucking Saturday. Really? And if it's like a college shifts or He was mad. It just was his failed his It's just ugly. They actually just
Like
ugly.
anything that all the other players don't want to do, they just get because they know you're going to say no.
I know.
They're all they swear to talk to you.
It's actually funny. Okay, wait.
This would, yeah, two bombs with you have 1, 2, 3, 4, 5, 6, 2, 2.
Am I leaving any of these there? Am I leaving?
Because they have other 2 open spaces. So there's 2 electrons for both. No, it's just, yeah, but like this one has 2, this one has 2.
This one doesn't have. Well, then, this has valence is the shell. Okay. So that I can.
That's a girl. That's 2. That this is 2.
So you're saying just put like one line here?
Yeah, just that's the no.
Oh, lone electrons.
Yeah, no. Everyone's assumption. You know.
Wait, but then this is the door.
Whatever has main more than 5 and 6. So this has more than 5. So it wants to fill up. So this doesn't have a figure. So it's more easier to use. Because it wants a full shot. So then it's more to use 2 of these together. And then this point and this and this is the full shot.
Yeah, it was so funny.
It's like a level.
That's kind of fun.
Yes. I can't run fast.
That's fun.
I asked him what was our dad in Korean, and he went to the knife and formation and harder. And I asked him, duct tape getting and butter chicken burgers. And you have duct tape getting. No! It's just like, he's vibing with it. No, well, he's probably busy, but I can have fun with it.
Yeah. I mean, yeah, it seems like you don't have a point, but
Well, he answered the wrong one. The most he thought thinks about it. He's just there and contemplates it.
So folks, are we getting frustrated? Are we finding this a little frustrating? Perhaps? Good. Okay. If you were on that side of the room, I've already told you. This is a frustrating process. The reason I show it to you is that people get obsessed with just putting the atoms together, because when we did the simple ones last day, you could just slide everything together, yes? Today, next, I'm going to show you a method of doing these atoms with, I'm going to show you a method, but I'm going to show you single bonds first. Tomorrow, no, after Friday, we're going to do double bonds. So you'll have to bear with me when we do it with single bonds, because single bonds, you'll be like, why am I bothering to learn this method? This method seems too complicated, but it will help you, and we'll come back to these double bonds later, and I'll show you how this method makes it Really nice. So what we're going to do is we're going to turn to page 99. Okay, page 99. And if you did successfully get the structures, give yourself a pat on the back. If you are wondering what they look like, here is carbon dioxide.
Okay.
Here is hydrocyanic acid. Here is carbon monoxide. And here is ethene. So if you're interested, those are what they are. Don't worry, we will come back to these later when we learn the method. All right? It's not that long. It sounds long because there's like 8 steps, but in general, you do it very quickly, okay? So page 99, you need to know how many electrons there are for in every group, but you guys already know that, yes? So we're good on that. You should also know, remember that helium has them together, but the other helium, they are not helium like that, but if you have beryllium, let's say, beryllium, they would be separate, okay? So there's nothing really new here. Valence electrons in each group, 1, 2, 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7. And when you're drawing Lewis structures, all the noble gases have 8 electrons, but helium has 2. All right, we're going to keep going now. We need to have a complete octet, blah-de-blah-de-blah. Non-bonding pairs are called lone pairs. We know that. Lewis structures are 2-dimensional. That's just so you know, the real structures are not flat. Okay, so this is page 100. Everybody needs an octet. There are some exceptions to the octet rule. Hydrogen, we already know about. How many does hydrogen want? 2. 2 shared electrons. A duet. Beryllium wants only 4, which is kind of weird. Boron and aluminum want 6. Okay. And I wonder, do I have it here? Was I clever enough to do that? No, I wasn't. That's okay. I'll show you tomorrow. So there's a way of remembering these. Do you know how some people call basketball b-ball? Yes? B-ball. We all know hydrogen does not need 8 electrons, yes? But in order to remember the other 3, you can remember a basketball. B-ball. B-ball. Is good? Okay, so they have less than 8. There are also going to be expanded octets, which can have more than 8. We will talk about those later. So don't worry about expanded octets right now. There are some rules that you have to remember right off the bat. And I think if you look in this little packet here, and we flip to the page right after this funky looking periodic table here, and it says how to draw Lewis structures. Okay, we're just going to hold on to that page for a moment here. All right. Hydrogen and fluorine And we talked about this yesterday. Hydrogen and fluorine have one gap. Yes? Therefore, they form only one bond. So they are always going to be on the outside. They will never be the central atom.
That can make it work. So that's important.
Okay? The other halogens all have 7 electrons as well. Cl, 1, 2, 3, 4, 5, 6, 7. They also have one gap. Therefore, one bond. And so they are usually form only one bond, and they will usually be on the outside of the atom. They are normally not in the middle. There are some exceptions, but we won't find those for a little while yet. There are exceptions, and those occur when Cl, Br, or I is the singleton atom. Do you see how we have ClO2? And the Cl is written first. Singleton, written first. Okay? That's the only time when they're going to go in the middle. Fluorine, though, never goes in the middle. Fluorine is just, and we'll talk about why a little bit later. The central atom is always going to be the least electronegative. You don't know what that word means, but it means the furthest left and down on the periodic table. So as you go this way, that's going to be your central atom will tend to be there, okay, rather than up at the top right, okay? Carbon is almost always central. It'll usually be the singleton. Do not put more than 4 pairs of electrons. Some of you, when you were trying to get those structures, had something that looked like this. What's wrong with that? Two, 4. 1 bond is 6, 2 bonds is 8, and now we have 10. If you have 10 electrons or 12 electrons, it is a problem. Okay? 10 and 12 electrons is not allowed. It is a problem. There are exceptions, but we'll learn those later. For now, no 10 electrons, no 12 electrons. Also, electrons must also always be in pairs. So I do not want to see this. No. Okay, those electrons would go here. Okay, they go together. So it should always look like that or that. Yes? Or you can have a bonding pair. So it's always pair, 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 pair. Never a singleton. Yes? I need to fix this and move it up. Fix. Move that up. There we go. Always think symmetry whenever possible. If you can make something more symmetrical, that's usually more correct than less symmetrical. Okay? So here we have our little handout, how to draw Lewis structures, and we are going to follow the 8 steps as we work through these examples. Number 1, we're going to count the valence electrons, and we are starting with CH3I. So I'm going to do CH3I over here. Count the valence electrons. That's always step number 1. So what we're going to do is we're going to say carbon. How many valence electrons does carbon have? 4. So I'm going to put 4 here. How many valence electrons does hydrogen have? Hydrogen has 1, but I have 3 of them, so it's going to be 3 times 1. Okay. And then I have iodine, which has, it's in group 17, it has 7. And now what we're going to do is we're going to add those all up. 4 plus 7 is 11, plus 3 is 14. Okay, so step number 1, count the valence electrons. What does it say in step number 2? Read step number 2 on your little sheet. Draw the skeleton structure. So what is a skeleton structure? It basically means figure out who the center atom is. Who would be the center atom here? Tell your partner, who's going to be the central atom? Carbon. If carbon is present, carbon will always be the central atom, and it's written first. Okay, so carbon's going to go in the middle. So the second thing we do is our skeleton structure. So carbon goes in the middle. And then we simply arrange the other atoms around it as symmetrically as possible. We have 3 H's, and we draw lines to attach them. So we draw a single line for each. So I have a hydrogen, and a hydrogen, 3 hydrogens, and I have 1 iodine. Okay, that's as symmetrical as I can make it. So that's step number 2, draw the skeleton structure. So put your central atom in and then join all the others to it with a single line. At this point, how many electrons have you used up? How many in that line, the yellow line? Yes? You can use dots as well. Yeah. I'm going to use lines just because it makes it tidier eventually. Okay? So we have 2 here, 4, 6, 8. We've used 8 electrons. All right? The third thing we're going to do is we are going to add lone pairs until everybody has an octet. Until all atoms have 8 electrons. But not who? Who shouldn't have 8? Hydrogen. And who else? B, which is beryllium. B. And what 2 elements make up ball? Boron and aluminum. And the number of electrons that they want is we want 2, 4, 6, 6. Okay? I'm just going to keep reminding you of those. We don't have to worry about them because we don't have any of those this time, but those are what we're just going to keep reminding ourselves of them. So who needs electrons here? Who does not have 8 electrons? Who needs 8 electrons? Does hydrogen need electrons? No, because it's got a bond that gives it 2 electrons. Does carbon need electrons? No, it has 4 bonds. That's 2 electrons each, 2, 4, 6, 8. It's got 8. How about iodine? Iodine has only 1 line, which is 2 electrons. So we're going to add lone pairs, and we're going to add them on the left, on the right, and on the bottom, and that would give iodine 8 electrons. And step number 4, we count the electrons in the structure and compare to step 1. So let's count the electrons in the structure. We have 2, 4, 6, 8, 10, 12, 14. Is that the same as in step 1? Yes. And if that is the case, then you're just done. Okay? Done. Unless it's an ion, in which case we'll do something different, but we're not learning ions today. Now, this is why I showed you the double bonds today. Would you have been able to draw this structure without using this method? Probably. Yeah? Probably. But what if it was mixed in with a bunch of questions that had double bonds and ones that didn't have double bonds? Would it be as obvious? Maybe not. So we're learning this method, and you'll notice there are 5 more steps. We're just going to do the first 4 today, and then we'll learn the next ones as they apply to other ones. And I would like to give you guys the last 10 minutes of class to write any quizzes that need to be quizzed. And if you want to work on your review, you can. Apparently, my answer key is like all out of sync, so I will have to fix that. I will post a corrected answer key on Teams, okay? For the 4.6a and 4.6b. Studying for your test is your only homework tonight. Yes. Binoxalate. It's HCO3. It's in with the hydrogen carbonates on the front page. Hi. Yeah. Why? Just because that's how it rolls.
But there's no reason for it.
Well, there kind of is, and that's because it only has 3 electrons, 1, 2, 3. So it will form a pair and a pair and a pair. Okay. And it's just kind of okay with just having 6. Yeah. So yeah, I'm good.
So then that would.
Yeah, that's perfect. Exactly. Beryllium doesn't want to take on, it wants 2 electrons. And you'll notice that a couple of these, like aluminum is a metal. Beryllium is a metal, but they're metals that are like right next to the line. So they tend to form a little bit covalently because they tend to be more like less metallic than other metals. And so they'll kind of bond covalently. Yeah.
With the hydrogen, it doesn't look like the metal or more elemental.
Doesn't matter, it's just these 2 electrons. Yeah. Cool. You might have Rana, she was about like 5 years older than me, and I worked with her when I first started.
Oh, it's like a.
Not as a student teacher, but she was like a mentor to me, right? Like she helped me along because I was like, I don't know what I'm doing. I'm a first year teacher. Yeah.
Is boric acid a thing?
Yes, it is, but it's almost like a bonus.
Yeah.
Think it's true.
I was like,
If you know your other ions.
That's not as funny. Is that what kind of student?
Yes. Yeah. Hi. Yes.
I wouldn't love that.
Yeah, so it's like if we bore.
And that is because, hang on a second.
Would be our.
Growing.
Sevens. Yeah, that's so. Have you done?
You're not putting hydro because it's an I, you're putting hydro because that's part of the name and it's actually plus element. Yeah? Exactly the same. So this is the official organic meaning. Yes, I did, and I should give back everybody's quizzes, actually. That's a good point. All right, let's see, where did I put those? They would be in this bag. No, they're in here. Few quizzes to get back. Jacob. John. Alex.
Thank you.
Lawson. Okay.
Yeah, that's.
Oh, yeah, I think it's like, bear. Yeah.
No hydro at the beginning.
My dog is free.
Which, you're right.
Last year, I've been last year. Last year, we did a rice jolly meal last year. Oh, that's really cool. I don't I love jolly.
Normally, Filipino
I might even.
It's on sale. Lazy, she's so good. My brother is a tasty.
The difference.
No, I think I have.
Okay, if I choose a calendar, I'm supposed to convert. But I don't even know how. But if I choose a calendar, I'm supposed to find like Joe.
He was telling me like, man, you're going to go to the
Joe, right? I don't know.
Yeah, but I was like,
He was telling me he's gone on to the hospital. He just walked through some field for like 2 hours. And he was just looking for him. He never got to his game.
bro, because I was telling him, I was like, bro, you should go to the station. He's like, no, I just get on.
Yeah.
I have no idea. It's like, you know, where the ones have like go for the students are. Like, you know, like kind of like down the road. Like this from right after. And I was like, where the fuck did we go?
Oh, did you want to see all the
He
shapes?
was on a mission.
No? I got all excited.
Maybe another.
Maybe another day.
Yeah.
There's 4, 7 and AL, and he goes.
I really like the way your phone is.
That's what it said.
Really? I like the trend of,
That's 6. So
I
that's.
was gonna do like test show Jay come up with yeah. I will even remember Friday or something like that.
Do one morning. It seems pretty easy. Did you see that one where they said for like somebody?
Yeah, so sorry, it's 5 big things.
I found walking out with Don't care.
I think we can.
Yeah.
Now, everybody goes.
5 big things.
Say.
Wasn't it like his brother, whoever commented it? He was like, well, my brother died of they were like a little plastic boots. Oh, that's not what he had.
You don't want to, peace out, sir.
This is why method is happy. The method makes us smile because we're like, oh, and we did not get a headache from it. Yeah? Yeah. Okay. Anyway, I have to.
I have to leave 5 minutes early for a netball game.
No problem. Yeah.
Spence.
Hi.
Was there a water bottle with you?
No, not that I know of.
Oh my God.
Don't forget your open house. I'll get it. Here goes. Put your pockets, things like that.
Woody.
Whatever.
It always works.
I get this. Somewhere in this room is my laptop.
Oh. Yeah, something. Been a minute.
I met you.
Oh, nice to meet you, good sir. Nice to meet you. Nice to meet you.
It has my tea in it. I really want my tea.
You didn't so good. You know, I understand.
Yeah, one line, two or three. I feel like that was like really. No, it's supposed to be. I was almost there.
You really did.
Not again. Still alive. Signatures.
Wait, did he really?
Yes.
I think it's like we're just this.
No, guess what? The math teacher used my thing as his example for in the class.
I did. Which means I have my tea, which makes me happy.
But isn't that so cute?
Because I just thought about it.
I drew the slide, he drew the thing. He did great. But look, he used my example because he said,
I'm dying.
Well, there you go.
I love mine. He's like,
That was a cool.
really easy. Like, they have to bring out like,
Don't carry it.
no, we're doing factory.
Did you say you don't carry a dead body?
What?
You don't put a dead body in the ground.
Oh, you don't bury it
like burying like another body on top of it, like a small animal.
Okay.
Because I know they hit that those stop.
We were walking down the road. Yes, we were talking like. We told her.
Okay.
Right in front of the open door.
I don't know if it's me or that's
No, it's not.
all the ones with my car. But I have questions.
Okay.
And then he just puts to his left and then.
You gotta double check for everything.
Yeah. So what's wrong? Yeah.
Yeah, there's a lot of mistakes in it.
Yeah. Oh, yeah. Okay, yeah.
And then
Yeah. Oh, and it doesn't have the tetrahydrate. Okay, cool. I need to fix that, okay?
okay, can you put what this from here? It doesn't need.
It does not need the rubber. Okay, cool.
That was confusing.
Yeah, so I can take that to this page and.
Proud of me.
I'm still proud of you. Done good. Okay.
My bad.
This one's me and
Uh-huh.
49.
Okay.
Cool. And then this one,
Yeah.
there we go.
Oh my gosh, yeah.
That's phosphite.
Yeah, it's phosphate. Yeah.
I didn't do this part yet,
Okay.
but I don't think it's deep though.
No. You're pretty good.
I mean,
No.
I'll stop.
No. Yeah.
So if I didn't find any.
If I need more, let me know, because then I can fix it. This was when we used to do this year, we used to be able to be like, oh, it's in.
Yeah, no, it was my other.
Yeah. Yeah, so I was like, well, and then I thought, maybe I'm super good. I was like. Right? So I kind of thought it would be nice, but the problem is as long as that is when I'm putting this. It's different for my grade 9.
It's understandable. It's like
Yeah.
if you were like doing like so many questions in a row, like what I did was I don't know how I did it. I got the mono. I think this is the natural move, but I drew really cool.
Okay, thumbs up in the Cell Hotel, please. Let's go. Quick. Thumbs up in the Cell Hotel.
Come on, man.
Yes.
Yeah.
Just my thumbs.
Fun, so
Pull them on it.
Yeah.
I'm going on it to still look at us all.
No,
This
so last day, there were lots of people on their phone when they were supposed to be on the phone.
Everybody, go put it in there.
this man.
Yes.
Phones.
Okay,
What's a phone?
Okay, so once it starts.
I know.
No. Is it okay?
Is that my phone? Do you have a charger?
I do.
What's a phone?
What kind do you need?
Pockets are empty.
Apple.
Cell phone?
Okay, if you're not in my class, goodbye, goodbye, goodbye. Those of you who are here, put your phone in the cell hotel.
My pockets are. I don't got anything.
You don't got nothing? Okay, that's fair.
What's a phone?
What's a phone?
What?
Review day.